and you were left with this. Again, I want you to write them in radical form. So what is this in radical form? What's the index? Okay, so this is read the fourth root of x to the first. You don't have to put the first in there. Okay, so that's how you would answer it. Is that okay? So let's pick one from 4 through 6. Someone pick one 4 to 6 there. Four, okay, great. We want these simplified, and if you ever have an integer, you need to check its prime factors, and this will help you simplify it. So do we have prime factors right now? No, so let's go get them. So you got 8, and what's that break down into? And 4 breaks down into, again, don't lose your factors up in the tree somewhere. But we can rewrite this as 2 to the third raised to the 1/3. Is there any questions on how we did that? Right, we have 1, 2, 3 2s, and that's where the exponent of 3 came from. A couple days ago, we talked about a little review on the exponent rules. And so this is a power to a power. Power to a power means you do what? What is it? You multiply exponents. So what is 3 times 1/3? Okay, so right, it's 1 because it's 3 over 3. 3 over 3 reduces to 1, so it's just 2. Okay? Is that okay?
The answer to 4 would be 2.
That's right. And then, maybe you knew that the cube root of 8 is 2. Okay, awesome. But again, this is for the bigger problems. This is what you got to do for them. This is kind of what I was saying to Cody a little bit ago. If you're doing a power to a power on this one, this would be a to the 2 over 5 times b to the 2 over 5. Can you simplify 2 over 5 at all? Okay, so then there's really no need to be there because this wouldn't be your final answer. You want this in radical form. The index in this problem is what? 5. And we don't have a group of 5 anythings, right? Okay, so you can't really go anywhere. But that's what you need to check. Do I have a group of 5? And again, right, this verifies that you don't have a group of 5 because you can't reduce 2 over 5 at all. So really, this is just going to be the 5th root of a squared b squared. Okay, because again, maybe you do a problem where you reduce it all down. You find all these factors and you group it all up, and then you're left with this. This is how the answer needs to be written. Okay, so again, we want to, we have this integer here, and we are trying to simplify them. So do we have prime factors right now? Okay, we better go get them then. What's 81 break down to? 9 and 9. What's 9 break down into? How many 3's do we have? Okay, so then what you want to do is write it 3 to the 4th. And don't skip steps, okay? 3 to the 4th, but that's still raised to the 3 halves. We haven't done anything with that exponent yet, 3 halves. We got a power to a power. So what do we do with our exponents? Multiply. So what's 4 times 3 halves? 6, okay? And then if you're not sure, right, there's, the step in between would be 12 over 2, which is 3 to the 6th. And 3 to the 6th is something. It's a big number. What is it? Hopefully it's this, because that's what they said in the last class. 729, okay, good. They were right in the last class. Is that okay? Right, we're just grouping. That's what fractions do. They just group. I'm going to do one more. Anything from 21. Well, let's not do 21 because that's another 81. 22, 23, 24. All right. Okay. Do we have prime factors? All right, what are the prime factors of 9? 3 and 3, so that would be 3 to the what power? Y to the 6th, still to the 3 halves. We got multiple exponents on the inside, so we got to multiply them all by 3 halves. So it'd be 3 to the what power? 3 to the 3rd. Right, because that'd be 6 over 2. 6 over 2 is 3. Y to the 9th. We don't have any fractions, so we don't have any indexes left. Kind of like what Zach was talking about earlier. Or what he's asking about earlier, right? If there's no denominator in your exponents, you don't have a radical sign at all. You just have 3 to the 3rd, which is 27. Y to the 9th. No more radicals because there's no more denominator in your exponent. How's that?